The third example, we have 24 z to the fourth plus 6 z to the third minus 45 z squared. So our first step is to still factor out the greatest common factor. So since we have leading coefficients that are greater than 1, we need to probably find something that can come out of these. So 24, 6, and 45. 6 goes into 24 and 6 doesn't go into 45. 45 is divisible by 9 and 5. So we need something smaller. 3 can go into each of these. So we'll factor out a 3. We have z to the fourth, z to the third, and z squared. So the greatest z that we can pull out is z squared. So 24 z to the fourth divided by 3z squared gives us 8z squared plus 6z to the third divided by 3z squared gives us 2z minus 45 divided by 3 is 15. Z squared divided by z squared is just 1. So that is what we have right now. We have a trinomial. We have z to the second, we have a z, and we have nothing. So we can probably use our x again. So this is a times c, this is b. So this is our a, this is our b, this is our c. So we have 8 times negative 15, which gives us negative 120, 2. So we need factors of negative 120 that equal 2. That's a pretty big number. So 12 and 10. We want this to be positive. So 12 times negative 10 gives us negative 120. 12 plus negative 10 gives us 2. So I'm going to bring my 3z squared down. My two factors, so z plus 12 and z minus 10. Now we have a leading coefficient that's other than 1, so that means we need to divide each of our factors by that, simplify them. So 3z squared, this gives us z plus, simplify this, divide them both by 4. 3 halves. These can both be divided by 2, so that gives us 5/4. We don't want to leave a fraction, so we swing the denominator in front. So we have 3z squared, swing this front, 2z plus 3, swing the 4, 4z minus 5. And just to do a quick check, we have 4z times 2z, which gives us the 8z squared, and 3 times negative 5 gives us the negative 15. So we have factored this completely. 3z squared times 2z plus 3 times 4z minus 5.